All right. Okay. All right. You ready? All right. Now, let's review for the midterm. That was actually kind of fun. Yeah, it's fun. So yeah, figure out how to do that, and I'll give you some extra credit. Okay. All right. So we're gonna work with. You have measurements first, right? Measurement. And that includes significant figures, scientific notation, right? Precision, accuracy, yes?
Yeah.
What else? Help me out here. Ask me some questions. Remember, this is your review.
Error.
Error,
Yeah.
yes, error. What is it?
Percent error.
Percent error, relative error, right?
Multiplying error.
Multiplying, dividing, addition, and subtraction of measurements. Correct? Excellent. Excellent.
Accepted value.
Excellent. Accepted value.
Experimental value.
Oh, there's one thing, there's a problem that I actually read, and I'll read it to you guys too. Remember when we had a problem like this? 40.29 plus 28.3. Okay, let's say 28.4. Okay, well, we know if we do the arithmetic, that's going to be 9, 6, 8, 6, right?
Yeah.
Correct? And then, because when you add or subtract, it's equivalent to the, what? No, the least precise, right?
Precise, yeah.
So this will be 68.7 will be the
Yeah.
answer, correct?
Yeah.
Yes? Now, what happens though, let's just rewrite this. Let's say that this number is 4.029 times 10 to the 1, and this is 2.84 times 10 to the 1.
Why would
Okay.
you do 10 to the 1?
Excuse me?
Why would you do 10 to the 1?
Because you have to move this over. Scientific notation has to be moved over, so there's only one significant figure to the left of the decimal point. Yes? And we have a... Okay. All right, very good. Okay, I'll be ready. Okay, so what do we do? What do? We simply add them. That's going to be 9, what?
Is it a
6.
multiplication or-
What's wrong?
Is it an addition you're doing? No, multiplication.
It's addition, but when you add significant figures in scientific notation, what's going to happen is going to be 9, 6, 8.
6.
What is it?
6.
6, right? Times 10 to the 1. But then, how do I know what to write it? How do I know that that's going to be a 7? Because that's going to be, I make that a 7. So I have to round this to hundredths place, correct? You get that? Easy? Yes or no? Now, that's not my point. Yes, what's my point? Yes.
Do you have to do that because of the amount of significant figures?
When you add or subtract scientific notation, the base 10 has to be the same. Otherwise, you can't add them. Can't do it. Can't do it. For instance, let me give you another problem. All right, add this. Add this. 6.48 times 10 to the negative 3 plus 48. Add that. What's the answer?
You can't.
What's the answer?
Well, at this point you can't.
Well, what's the answer?
10 to the minus third, that would...
Well, no, you have to say, no, you have to, all
648, something like that.
right, what would this be,
4.8 times 10.
if you're gonna make it negative 3?
That.
How would you make that negative, 48 is negative 3?
4.04.
So in other words, it's actually 4.8 times 10 to the 1, but I wanna go the other way.
0.048 times 10 to the minus third.
No, it has to have the same value.
0.0.
No,
480.
no, what would it be? or you know what, it'd be a little bit easier to see conceptually.
Oh,
Make
4
that
minus
10 to the 0. Because this is 10 to the 0, isn't it?
Yeah.
Make that 10 to the 0. What would this be, 10 to the 0?
648.
0.00648.
What is it?
0.
So it would be 48 times 10 to the 0, and then this would be what?
0.00.
Yeah, 0. Point,
648.
yeah.
Okay, so it would be, and this would be what?
0.00648.
0.
6.
648.
I know.
No, just nothing.
Yeah. To the 0.
Okay. So what do you have to round it to?
120.
So 2 cents.
Why don't you complicate your life so much? You just like, just use the normal numbers unless it's like a really big number.
Because my point is simply this, that these values here, if you're going to use scientific, either use scientific notation completely or don't. I'm going to read the first question.
But if we have like just -3 or like to the 10 to the third or 10 to the second, can we just like not use scientific notation?
If you want, I don't care how you do it, you got to get the right answer with the concept that your answer has to be as precise as the least precise value.
Okay.
So it says, what is the result of adding 2.5 times 10 to the third and 3.5 times 10 to the second? If you use that with a calculator, how do you know what decimal place I rounded to? You don't really know, do you?
Precise.
You round it to the least precise, but how do you know what that is? By just looking at it.
Okay,
Could you repeat that?
Can we do another problem?
Yes.
I'll do one more problem. This final exam is going to be more than adding measurements, okay? All right? 6 times 10 to the first, let's make it a little more interesting. 6.85 times 10 to the first plus 3.2 times 10 to the second. What would you do?
you would.
You would just
Change the.
You're going to change this times 10 to the second or this times 10 to the first, right?
Yeah.
All right, so what is it? What are you going to do?
1.685 times 10 to the second.
0.685 times 10 to the second? Okay, good. 0.685 times 10 to the second.
Plus 0.33, no, sorry,
3.2.
3.2 times 10 to the second, and that would give you
3.885.
Yeah, 3.885 times
Yeah.
10 to the second.
Right, is that correct?
Yeah.
Mhm.
Actually, no, it's
And
not. The least precise.
So what's the answer?
3.9
3.9.
times 10 to the second.
Okay.
Yeah.
Easy?
You have to round it up to
He
the
wasn't
least
here.
precise one.
I know he wasn't here, but you're not taking the midterm, remember?
Yeah, I am actually. You told me.
Yes, but it doesn't count.
Yeah.
Doesn't
Because you
Yeah.
just arrived.
All right.
Okay, worry, that's a good thing, but you looked completely shocked. You okay?
Yeah.
Yeah. Because this isn't about math.
No, I got the.
This is about accuracy and precision.
Yeah.
Adding and subtracting data. So what else do you have? You have multiplying measurements, you have dividing measurements, subtracting measurements. Yes? What else? We said this already.
Error. And
Error, percent error, relative error,
accepted value.
accepted value, all that stuff. Yes?
Yeah.
Okay, are you okay? I wouldn't go too crazy with error, with measurement. It's not that hard. You just have to dust off a few things. Yes,
Would you recommend knowing the formulas like error equals experiment?
absolutely.
Yeah.
Yeah. Remember, you have four sides of a piece of paper, A4. So put on it whatever you want. I'm not giving you any formulas. I'm not giving you anything. So I would strongly recommend knowing all of your formulas, etc. Clear?
Sir, there's like a lot of information on it, like written really small. Would that not count as presentation? Because You're gonna pick it up, right? You told us, right?
I'm going to pick what up?
The
That line, so.
I'm going to grade them.
Yeah, you're gonna grade them.
Yes.
So if they're like really cramped and there's lots of stuff on it, is that like bad for presentation marks?
No, because I'm not the one that has to read it.
Who does?
You are.
You.
You need it for the
I'm not
stats.
going to grade it based on the eyes of a 58-year-old.
Okay. And
Mustafa, are these questions best served for the review of someone's midterm, or shall I move on?
no, I want to ask a question. Just
Okay?
what should we do on what should we put on the outline for a good grade for the outline?
I'm not telling you,
How come?
because you have to figure that out. That's part of the whole concept of grading it. You have to be able to determine that, and you're certainly old enough to do that. What else?
That's it.
Is that it? Okay. Now, temperature, Celsius, Kelvin, Fahrenheit. I apologize. I don't think I put any Fahrenheit on this, actually.
It's a good thing.
Yes, yes. So says the Egyptian. I know. Believe me, the United States is backwards.
Yeah, we are.
I know. All right. What about so Celsius? Oh, dimensional analysis, converting from centigrams to nanograms. Okay. Could you guys we're working here? Yeah, yeah. I'm deaf, and I can hear you, and that's probably a very sensitive audio pickup, so they probably hear you too. Okay. So, what else?
So how long is the test?
50 questions, multiple choice. It's very, very basic.
That's it.
Yes, that's it. You only have 90 minutes to do this. It's not like you have several years. So what else is going to be on it? Chapter 4 is atomic structure. What's atomic structure about?
The mass
Structure.
number.
Using SI units.
Yeah, protons, neutrons, electrons. What else? Throw me some words out.
Isotopes, mass number.
Nuclei.
Nuclei. What else?
The models of the atom.
No.
Atomic size and
There might be.
size?
Yeah.
What is it?
Atomic size and all that.
Atomic size radii, atomic radii. Remember that's chapter 6, the atomic radii, ionic radii,
Orbitals.
ionization energies, orbitals, long form electron configurations, short form electron configurations. Shall we do a problem, very basic, pick an element between 1 and 100 and, I don't know, 100, 92. Excellent, I like that. Uranium.
Uranium.
Okay, uranium. Okay, how would you write uranium? How would you write that? What's the dominant isotope for uranium?
+4, I think.
No, those are ionization energies. I mean, oxidation numbers. I'm talking about the mass. 239 on the table. What is it? 238. Okay, good. 238 and 92. Remember, you got to know what isotope is.
Yeah.
Yes.
Yeah.
You got to be able to calculate and know the difference between mass number and atomic number. I'm sorry, mass number and mass weight. Correct? Yes, know the difference between those. Where the mass number is simply the total number of nucleons, and then the atomic mass is going to be, or the atomic mass is going to be what? The average of all of the isotopes of a particular element based on the percent abundance. Okay, what did I say? Mass, weight? Is that what I said? I'm sorry, I was confused. Couldn't make up my mind, mass and weight. Atomic mass. We don't say atomic weight, but anyway. So let's do a bunch of things. Let's do the 4 quantum numbers. Let's do what's NLX for uranium?
92.
No. What's that mean? Remember? What's that? You have a periodic table? Could I borrow that, please?
Yes, sure.
You guys don't remember?
It's
It's 7 actually.
No, it's 5.
L is F.
5F4.
Yeah, 5. Oh.
Okay, 5F4.
Yes.
You'll live.
Oh wait,
Ain't it?
Based on where it is on the periodic table, its final orbital, suborbital. This is a Darcy notation. I apologize. I call it NLX. That's just that means the principal quantum number, the sublevel, and the number of electrons in the sublevel. Okay, that's just my notation, NLX, kind of rolls off the tongue, yes? Okay, so what is the long form electron configuration going to be?
1 is 2, 2 is
Go ahead, Fabiana.
1 is 2, 2 is 2.
1s2, 2s2, 2p6, okay, along with me, 3s2.
3p6, 4s2. Oh.
You guys are good.
4p6, 5s2, 4d10, 5p.
You guys are terrible, terrible.
6s2, 4f, yeah, 14.
Wait.
Yeah,
Yeah.
keep going.
You guys are so bad. I'm embarrassed. People are saying all over the world, what a mess that class is. Okay, do you realize you're going international? Okay, I should turn this camera around and show everybody.
66.
What is it?
66.
6p6.
And then
7s2. It's 5f4.
yeah.
No.
Enzo, you're discovering something new. Remember, you weren't really working very hard back then, so you're finally making connections. Very good.
Yeah.
No, I understand completely. I'm teasing you. It's fine. So you get it? And then what is the short form?
Wait. I know the name. YB. Is that
YB, not YB. What's the nearest preceding noble gas? I wrote 3s3 where? Nice catch. Excellent. Nice catch. Excellent.
5p6.
Now, what is the nearest preceding noble gas?
7s.
No, we don't talk that. We actually say it. Is it argon? Is it helium? Xenon? Radon? Is it radon?
Yes.
Yeah.
Yeah.
Why would it be radon? Why do I automatically know that? Why is it radon? Well, the atomic number of radon is what? 86.
Yes.
And this is 92.
Yes.
Yeah. So radon. And what?
And yeah.
Okay. What is the set of quantum numbers? Well, I know right from NLX that it's going to be 5, 3,
Yeah.
because it's F, right?
Plus.
And then what about?
That's positive 1/2.
Yeah.
On the
So this is going to be
And then plus 1/2.
It's the right out.
plus 1/2.
Wait, isn't it?
Yes, it's plus 1. Yes.
But isn't it the fourth?
Yeah, but 1.
Isn't it
No,
5F4?
Is it 0? No.
Yeah.
Yeah?
Isn't it 5F4?
Yeah.
Okay.
0.
Yeah. 5F4 would be -3, -2,
I'm gonna
No, but,
-1, 0, plus 1,
Yes.
plus 2, plus 3.
But we're talking about the other box, like after that.
Oh, I'm talking
You know-
about that box. 0.
Oh yeah, yeah.
I
zero,
know what you're
then-
talking about. That's fine.
Yeah.
Yes, it's like a scala. Yeah, I know what you're talking about. But do you understand M? What's M? Has it been too long ago? Another lifetime,
S.
maybe? Abby's looking at us like, was I here?
SB, the
Yes.
You remember those the table you gave us where we had to fill in all the stuff, like M and S and all that. We gave it into you as homework, but we could use that too.
I gave it back. I gave everything back.
Yeah.
Everything back. But that's not the point. The point is being able to do it now, not looking back on something a long time ago. This is pretty basic stuff in terms of the chemistry this year, right? What is it? 0? What is it?
So M is like when you.
Yeah, M is
the shape out all the way.
M is the shape, right? This is D.
Yeah.
This is P.
and
That's S, right?
S is 0.
This is 0, -1, +1, -2, etc. No?
Yeah.
Yes, maybe, could be.
Yeah.
You guys are looking at me like I'm a little crazy. Okay. You get it or no? You okay with that? So what would M be for uranium? Now that the entire world thinks that you are a mess. what would it be?
Zero.
Zero, that's right, zero. And then.
And that's plus 1/2.
Yeah, and they say, when you do this, you have to have like let's say you're taking the AP chemistry exam. This would be right for all of them, boom, 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 just put 5, 3, right? But then it would say on the exam that you have to say, the first one is positive and the second one is negative. See? You have to come up, and in here we have as our class standard, the first electron in is positive 1/2 and the second one is negative 1/2. But that's something to organize yourself around, yeah? Okay? Get it? What else? Is that it?
Yeah.
Yeah, easy?
Yeah.
Okay. What else? Electromagnetic radiation, correct? What's the main equation for electromagnetic radiation? What's the main equation for that?
Electromagnetic.
Well, actually, there's two equations that organize how you have to know what the amplitude is, the wavelength,
Yeah, you're talking about
wave mechanics, the period. Right? Shall I write it down in symbols?
Oh.
The
Yeah,
wavelength.
that's,
bad
The frequency, which can be also shown as like this. It's also frequency, the letter nu. What did we use? F or nu? Yeah, nu, yeah. C is the velocity. The period is actually that. What's the period relative to the frequency? Do you remember?
We never.
We didn't really talk about it a lot,
no, we
but
didn't.
it's what?
The inverse.
It's the inverse. In other words, if the frequency is 1, the period is 0.1. It's just the reverse. Okay. What's the amplitude?
The size of the wave.
The size, amplitude.
No.
What's a node?
It's how you measure.
Node.
A node.
A what?
A node. A node. It would be this. It'd be a line right through here.
And or the yeah.
What are the equations that relate these things? What are they? What are the main equations that relate them?
Okay, see.
Right?
Yeah.
What's the one for period?
It's E, energy equal H.
No. No, you're right. That's another one. That's for period. And what did we say for energy and Planck's constant? Which one did we say? Annabelle, that's what you're talking about. The energy is proportional to the frequency, correct? And then Planck's constant is the relationship constant, correct? Easy? We didn't spend a lot of time on that. I wasn't really worried. You get beaten with electromagnetic radiation. We're going to do a lot next year, or you will do a lot next year. What else? All right. Shall I read some problems
Yes.
from this? Okay, you ready? All right, here we go. What is the result in adding 2.5 times 10 to the third and 3.5 times 10 to the second? What is the boiling point of water in Kelvin? Whoa, that's a tough one. I'm being sarcastic.
Yeah. If you know.
Which of the following is correct concerning subatomic particles? It's who discovered them. Let's see. The atomic mass of an element depends upon the. I was going to say elephant. I know. Does it sound like that?
Yes.
Yeah. The atomic. I was trying to cover that. Yeah. The atomic mass of an elephant depends upon its trunk. No, depends upon what? Okay, let's see what else. Which is the following electron configuration of the outer sublevels? Did I read that right? Which of the following electron configurations of outer sublevels is the most stable? Ooh, that's a good one. Here's one I read today to the other class. What type of hybrid orbital exists in the methane molecule? Good one, huh? You like that? Abby likes that. I like that.
Hybridization.
Is it?
SP3, yeah, it's about, yeah, SP3, right? We went over that. Anything that has a tetrahedral shape and uses carbon, SP3. Rule of thumb. I just don't have time to think about any exceptions. Okay. Oh, that's in here. Isn't that interesting? Under what conditions can potassium bromide conduct electricity? I like that. I like that a lot. I didn't realize, I'd forgotten that's even in the book. We didn't talk about that much, but oh well, it's out of the book. One more. Let's see. And does anybody know under what conditions? Whatever I said, what did I say?
Potassium.
Potassium bromide can conduct electricity?
Hot conditions?
It's melted. Sodium chloride too. Matter of fact, I did a problem today where I talked about sodium chloride and, you know, when you can decompose sodium chloride, and the way you can decompose sodium chloride, it has to be in molten form, because if you dissolve it, you can't do it because the oxygen, the water will decompose. And if you heat it in air, it will, you know, form other compounds. So that's a good one. I like that. All right, let's see. There was another one where it said, this is a good one. You ready? Here's a good one. What is the electron configuration of the oxide ion? What would the electron what would have the same electron configuration as the oxide ion? Anybody? Just look at your periodic table. If it takes you more than 1.5 seconds, you don't know what you're doing. Excellent. Well done. I think Annabelle, I think you said it at the same time. So who owes whom a Coke? Oh, she said it too? South African? Excellent. 3 points for the South African team. Excellent. I like that. I like that. The Diplomatic Corps in Pretoria should know about this. Excellent. Excellent. Well done. Excellent. All right, are we done? I'm done. Yes, easy? Yeah, you can do just this one problem and you can.
Okay.
Oh, by the way, atomic radius, ionic radii, ionization energies, trends, important. You should do very well. This is far too easy. I think I'm going to have to go and do a harder exam,
It's fine.
and I'll make up probably
It's fine,
85
fine.
free response problems,
No.
and maybe 5 or 6 essay problems that take at least 4 pages to write. I've had teachers like that. The whole point of a final exam is to have it general enough and easy enough that you not absolutely easy, but that you can see the overview of the course. Because when you study periodic table, you're only looking at that. You know, that's why the final exam is going to contain information from the first semester. Most people, when you take a final exam, it's the second semester, right? Well, everything in the second semester is dependent on the first. I want you to have an overview of everything. Yeah? Easy?
Yeah.
We're off.